Okay, this video is what we're going to be doing is looking at quadratic and rational inequalities. Quadratic means things with like x squared. Rational just means, things with a fraction. So things like this. Here we have a quadratic equation on top or expression on top of a denominator, so it turns into a what? A rational expression. But this time it's not equal to zero, it's greater than or equal to zero, or it can even be less than zero. Yeah, here's this. Less than or equal to zero. Okay, but let's begin with just a few preliminary things. They want you to write the inequality in interval notation. Now you need to know how to do this because the teacher wants your answer in interval notation. Okay, now you always want to write something in terms of you want to begin with an inequality like greater than or less than sign, and then turn that into a line graph, and then turn that into an inequality. Okay, so you do want to take your steps. A lot of students have made mistakes because they try to just skip a couple of steps. All right, so what is this? P is no more than 2. Now, why can't they just say P is less than 2? So P is no more than 2, so it has to be, if it's not more than 2, it has to be less than or equal to what? 2. Now what I'm going to do is, again, put this on a number line real quick. All my possibilities of P equals 2 and less. And I'm going to always draw my interval notation based on the number line, not based on this guy. So here we have your upper bound, the highest number that P can possibly be. And then you go left infinity, right? So we'll put comma and left infinity, and there you have it. This is your interval notation. Q is no less than 5. Why do you have to write it like this, right? Why? Q is no less than 5, so it must be greater than or equal to what? 5. Again, you want to draw a number line. 5. All the possibilities of Q is equal to 5 and above. So now, based on the number line, we can draw our interval notation. And notice it matches up. Left side, right side, right side. Okay? Left side is closed, so it's a bracket. Right side goes infinitely to the right side, so we put the infinity sign on the right side of our interval notation. The one on the right is always the upper bound. The one on the left is called the lower bound. Here we have a conjunction. It just means something right in the middle. Negative 2 is connected with 10, with all the x's connecting all those. So, all right, so how do you do this? It's already written in inequality form, so we just turn this into a number line real quickly. Open circle here because it's greater than negative 2, and less than or equal to 10. And it's all the numbers in between. And so again, lower bound, upper bound, left side, negative 2, right side, 10 with a bracket. And side note, one student asked me, will you ever have a situation something like this where 2 is like this, like that, where the inequality is facing, instead of this, it's facing like that. No. Okay. Well, okay. I take that back. Yes, sometimes, rarely. Okay. And also, you'll never have a situation where it'll be something like this, where they're either like this or like this. All right. It's always going to be like this. Okay. The smallest number on the left, the biggest number on the what? Right. By any perchance, if you ever see something like this, you got to split it into two separate inequalities, like x is less than or equal to negative 2 and x is greater than what? 10. It becomes a disjunction. But I've rarely seen this, and I don't think it's going to be on the test, okay? So it's always going to be like this. Less than on the smaller one on the left side, the bigger one on the right. Okay, so let's move on to this. It says here, write an inequality that represents the interval and state whether it is bounded or unbounded. Bounded means it stops. Unbounded means it keeps on what? Going. This is obviously unbounded to the left. Make sense? It's bounded on the right. 10, negative 10 is as far as it can possibly go. So again, you could, I always convert it to a number line. It just makes most sense. So we got negative 10 here. Closed circle goes, all the possibilities of x are less than negative 10. So x is less than or equal to negative 10. Okay. Again, you read the instruction carefully. Write a what? Inequality. The instruction on top says, write the inequality in interval what? Notation. So this is interval. So we got inequality, line graph, interval. Okay. All right. So it's here. Okay, so it's bounded on the right because negative 10 is as high as it can go, and then left is unbounded. Here we're bounded on the left side. Let me rewrite that. So this is 4. And it's an open circle because the parenthesis means it's not going to touch 4. And all my values will go to the right. You can say these are all my x values. X is greater than 4. It's bounded on the left, unbounded on the right. So we say x is greater than 4. Here, we're both bounded on both sides, okay? So this is like negative 7, open circle, to close circle, and everything between. All the possibilities, we'll just call it x. So we'll say negative 7 less than x less than or equal to what? 2. So notice how the inequality and, well, in this sense, the number line and the inequality matches up. 7 on the left, I'm sorry, negative 7 on the left, 2 on the right. And the inequality goes in the same direction, okay? All right, I'm getting bored, right? I'm getting so bored. No, I'm just kidding. All right, negative 2 to 2, negative 2 to 2, close circle, and everything in between. So negative 2 less than x, less than or equal to 2, all right? Okay, now this one, you just solve it. Just solve it. There's really nothing here except just solve for x. But yeah, I'll do it for you though. Okay, so first thing we want to do, there's several things you can try. You can either distribute it in and then gather all the x's together. Fine, you can do that. Another thing is there's a fraction and height fractions. So let's multiply everything by 2 and get rid of this guy. Whatever you do on the left, do it on the right. So if I multiply the left with a 2, I multiply the right with the 2. The left side, the 2 will cancel out. You have x, 8 minus x greater than or equal to. If you multiply the right side with a 2, you'll get 8. 5 minus 2x. Now be careful. Don't take the 2 and think, oh, I have to distribute it to the 4, 5, and negative what? 2x. You only do that if you're actually multiplying the parentheses. But again, you have 3 numbers that are being multiplied. 4 is one of them. 5 minus 2x, it's inside a parenthesis, so it's just another. And you're multiplying everything by what? 2. So you can decide. You can go 2 times the parenthesis first or 2 times 4. You just can't do both at the same time. I'm going to give it to the 4. So it'll become 8. And then you're going to distribute 40 minus 16x. Again, you have x to the first power, meaning you don't have an x to the second power. As long as it's x to the first power, it's just a linear equation or a linear inequality, and just isolate the variable x and you're done. Let's move the 16 to the left side, 8 to the right side. So we get 16x minus x greater than or equal to 40 minus 8. So that'll be 15x greater than or equal to 40 minus 8 is 32. So x is greater than or equal to, divide both sides by 15, 32 over 15, and you are done. Do they want the answer in interval notation? If so, again, start with the number line, 32 over 15, and all my x's are greater. So this would be 32 over 15, comma, positive what? Infinity. Same thing with this. It's just that it looks a little bit complicated, but again, what am I going to do? I'm going to multiply both sides by 3, or multiply all 3 sides by 3. Is that? 5 times 3 is 15, so this would be 15. And then in the middle, the 3's will cancel out. So in the middle, you have 2x minus 5. And on the left side, you'll have negative what? Negative 9. Okay? And then, okay, I'll just finish it off. You got to add 5 to all 3 sides. Wait, that kind of looks weird. I have 2 inequalities. Okay, I think I think I'm getting sleepy. Okay, so we got here negative 4. Oops, let's do green color. Negative 4 less than or equal to 2x less than 20. And then what do? Divide everything by 2, so you can isolate x right in the middle. So you get negative 2 less than or equal to x less than 10. And that's basically negative 2 comma 10, open circle. Okay, now the real difficulty of this is not all of that, it's these, okay? All right, now it's going to take a lot of energy to explain this, and I'm going to try to pull out as much energy in me as possible. I'm so tired. Okay, so again, it's a quadratic, right? If it was equal to 0, you'll just set it equal to 0 and solve, but something strange is happening. We want everything to be less than 4, or if you move it to the other side, we want it to be, oops, less than 0. Now, anytime one side, like the whole side, is less than 0, it just means we want all the x values that we can plug into this, solve it, get the answer, and it should be a negative number. We want a negative number. Negatives are less than what? 0. How do we figure out what numbers are less than 0? Well, can we figure out what x causes it to be 0? Now, you might be thinking, why that? Well, we want to find numbers that are less than 0, right? So that means all the numbers in the universe on a number line, if you plug it in, it will either cause it to be a negative, a positive, or 0. So if you can figure out which one causes this expression to turn to 0, the rest of the numbers will either be positive or what? Negative. Now, if you don't get that, rewind it and listen to it again. It should make sense. Okay, so let's factor this out. I need to move this over because I'm going to run out of space. I don't know why it's not moving. Oh, there it goes. Look at that. Woohoo. Okay, so I'll just move it there. And, okay, oops. All right, so again, factor it, set equal to 0, or solve it as if we're solve it as if we're 0. Oh, I can't even say it right now. Okay, so we're going to do the x method. 6 times -4 is -24. And then 5 on the bottom. I think we did this. 8, -3. And then we do our grouping, x6x squared plus 8x minus 3x minus 4 less than 0. And then we got, let's see, what can I factor out? We can factor out a 2x, 3x plus 4, and factor out a -1. It'll be 3x plus what? 4 again. It matches up, and I almost made the mistake of putting less than or equal to 0. Okay, so this is just a long, drawn out, this is not really even the answer. We're just doing grunt work. Okay, now that we've factored this and made it less than 0, notice if you set both of them equal to 0, you'll get x equals 1/2. X equals -4 what? Third. Now what does that mean? It means that on a number line, okay, so you gotta look at it like this. A number line has infinite amount of numbers, right? And we can choose any one of these and plug it into this equation. When we do that, some numbers that we choose to plug in will make this expression positive. Some will turn it into negative. Some will become 0. So if we can isolate which one turns into 0, like these two guys, if we plug these two in, it'll become 0. And I'm going to put an open circle there. What did we just do? We've divided infinity into 3 segments. Here, here, and what? There. And because they're, numerical order, like numerical or least to greatest, if I choose any number less than -4/3 and I plug it into that expression and I get, let's say, a positive number, that means every number that I choose on this side will make that expression positive. Let's say that I choose a number in here and it becomes a negative. That means anything inside here between these two will cause that to become a what? Negative, which is basically what we want. So how do we do this test? Well, notice that we have 2 parentheses. Best, just go like that, like that, like that. And again, we're not worried about the actual numerical value. All we want to know is if it's going to be positive or negative. So watch this. What's the number less than -4/3? -2. So plug it in. If I plug in -2, this will become -4 minus 1, which is a negative. Again, I'm not worried about the actual number because negative times something well, if it's negative, it will become positive. Oh, let's see what happens. We plug in negative 2 here. We get negative 6x plus 4, which is a negative 2. That's a negative. Negative times negative becomes ultimately a what? Positive. Do we want all the numbers less than negative 4/3? No, we want it to be less than 0. So, shabam. Okay, let's choose a number between negative 4/3 and 1/2, like 0. If you plug it in right here, you get a negative. So I put a negative sign. If you plug in 0 right there, you get a positive 4. That's the positive. Negative times positive becomes negative. Do we want those numbers? Yes. And then it usually alternates, but not always. You got to be really careful. So you have to check everything. So choose 2 or 1 or anything. So if I plug in 2 right there, you get a positive. Okay, if you didn't get that, 2 times 2 is 4. 4 minus 1 is 3. That's positive 3. Positive. Okay. 2 times 3 is 6. 6 plus 4 is 10. So that's positive. Positive times positive is positive, but we don't want positive numbers. So our answer lies right over what? Right there. So our final way of final way of presenting our answer is this. Interval left is bounded on the left with negative 4/3 and is bounded on the right, meaning every number between these two will make that expression less than 4 or that expression less than 0. They're equivalent where we are done. Okay, I'm just gonna do one more, okay? Because I think I'm losing it. So I'm gonna do this one pretty fast. Maybe 2. And if I feel all for it, I might even do 3. But I'm getting really hungry. I need some peanut butter. And I don't even know why I'm talking about this. I should be professional. Okay, so x, screw it, blah, blah, blah. So let's factor this out. X plus 4, x plus 3, right? And I did that really fast. Notice you got 3 parentheses here. 2 on top, 1 on the bottom. And we want this to be greater than or equal to 0. So 1. So there's 3 numbers I need to look at. 0. Wait, let me put it right here. 0, negative 3, negative what? 4. If you set that equal to 0, you get negative 4. That will get negative 3. This will produce a 0. Now, but 0 is on the denominator. That will turn this whole thing undefined. We don't want that number, so we put an open circle there. Do we want these to be 0? Yeah, we want it to be greater than or equal to 0 because anytime you have a 0 on the numerator, it will produce a 0 as a fraction. So yes, we want those two. But notice, now we've separated this number line of infinite numbers into 4 segments. Now we have to test 4 areas like this. Oh, now I'm going to use the green line as a fraction bar. See that? Okay, so if I test a number less than negative 4, like negative 5, and I plug it into this expression, you'll get a negative, 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 and it will become positive on top, positive and negative. So this whole thing will become a what? Negative. Do we want those? No, we want it to be greater than 0. So we cancel that out. All right, something between negative 3 and negative 4, like negative 3.5. Negative 3.5 here will be positive, negative, negative. We get a positive. Do we want those? Yes. And something between negative 3 and 0, like negative 1. If I plug in negative 1, that'll be positive, positive, negative, but that'll turn into a what? Negative. Again, positive and positive makes negative, divided by negative, turns the whole thing negative. Do we want those? Nope. Let's test 1. Positive, positive, positive. So yes. So our answer is here, here, and here. So our answer is negative 4 to negative 3, bracket, U for union, open circle at 0, and positive what? Infinity. So that's how you write your answer for this one. Okay, I'm gonna have to stop here because I am just not feeling too good because it's getting really late. This one, just move the 1 over x to the left side, get common denominator, and turn it into something like this. Okay, that one, factor by grouping, and basically do it like that. If you have any questions, text me later, okay? All right, have a good night.